Next one is the software components. There are four different types of software components are there: protocols, device drivers, network operating system for the next layer These device drivers are actually provide an interface between your device and next one is the software components. There are four different types of software components are there: protocols, device drivers, network operating system for server, and network operating system for clients. I've already explained about protocols. Protocols are actually nothing but a set of rules that the computer on the network must follow to communicate with each other. If two computers want to communicate with each other, a set of rules are they must share, then only they can communicate. They are called as actually protocols. Next one is called the device drivers. Device drivers are actually programs that control the functionality of the hardware device. Whenever you attach a new hardware to your computers, you need some programs that is called as device drivers. These device drivers are actually provide an interface between your device and host operating systems. For example, if I install a NIC card in my computer, I need NIC driver. This NIC driver provide or control the control of NIC, means network interface card, to the operating system. Means the operating systems can communicate with NIC by using NIC driver. Like that, if you have any components or any device in your computer, for each device there are some programs are there. That programs is called as device drivers. And then the next one is called as computer operating system for server. We need two types of computers. It's a combination of hardware as well as a software. We need two types of computers called as server and clients. Here the server will provide some service to the client. What is the meaning of server? Server means the operating systems. They are specially designed and developed for providing services and shared resources to the client in the network. That means these are the operating systems which will provide some service and some shared resources like hardware or some software or some files. These are giving to the client machine. At the same time, some client operating systems are there. They are making some requests to the servers and take the service of or files of that servers. Such operating systems are called as network operating systems for client. Network communication standards. First, what is the meaning of standard? Standard means uniformity. For example, there are so many different manufacturers are there who are designing different devices, different protocols as well as softwares. A particular standard has to be maintained to give the uniformity. Otherwise, the device developed by one manufacturer cannot communicate with the manufacturer created by another company. For that one, some standard has to be maintained. For that, some models are designed. The first one is called as OSI reference model. Second one is called as TCP IP model. The first one is OSI reference model. This OSI reference model is actually also called as Open System Interconnection. It is actually designed by International Standard Organization, shortly called as ISO, during 1983. This model is actually designed to connect the systems that communicate with each other regardless of different protocols. This model allows computers from different manufacturers to communicate with each other. That is, there is no need of any changing of software and hardware. This OSI model actually contains 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The four first four, that is physical, data, network, and transport layers, are also called as lower layers. The remaining 3 are called as upper layers. This OSI reference model is actually work on layered system. Layered system means networking is actually a difficult job, a very big task. The task is divided into smaller parts, and that smaller parts are completed by each layer. It is just like if you want to send some mail to your friend, first you have to write a letter and put it in a cover, write a address, then you have to go to the friend's area or house and you have to deliver it. It's a very difficult job. So what actually we are doing, we are writing the letters, put it in a cover and write an address and deliver it to the mailbox. This mail is actually taken by the postman and deliver it to the post office. In the post office, the letters are sorted and given to the carrier. Then that post carrier actually send that letter to the destination. At the destination, it is received at the destination post office. Post office actually sorted it again and give it to the postman. Postman deliver it to the mailbox of the destination and your friend get the mail. Here a number of layers are used, each one working their own task. Like in similar way, when you are sending some information in a communication medium, we are also using the layer technique. For example, when you want to send some data from computer A to computer B, a number of 7 different layers are used. Whenever you are sending a message, each layer add its own header and tailer to the data and send it to the next layer. These layers take some of the service from its bottom layer. For example, this data link layer takes some of the service from physical layer. This this network layer takes some of the service from data link layer. When any message has to be sent to the computer B, if computer A want to send some message to computer B, it is given to the application layer. Application layer attaches some of the headers and footers to the data and give it to the presentation layer. Presentation layer adds its own data, header and footer and give it to the next layer. This process continues until it reaches the physical layer. In physical layer, it will convert the data into signals and send it over a medium. At the destination, the physical layer receives the same signals and converted that into data. Then data is actually given to the data link layer, where it will just remove the header and trailers, which is provided by the source data link layer. In the similar way, it is given to the network layer. Network layer again remove the header and footer provided by the network layer by the source. Like this process continues until it reaches the application layer. Application play layer interpret that message and give it to the computer D. Like that the communication will be done. Physical layer. This is the first layer in OSI model. The use of this physical layer is to transmit data in the form of bits by using some physical media. This physical layer converts the bits into either electrical or optical signals and transfer that over a transmission medium. This physical layer identifies medium used to establish a connection between two computers. It will understand which type of medium we are using, whether we are using twisted pair, coaxial cables, or optical fiber, or wireless. It will understand which type of medium we are using and transmit the bits. Physical layers use the type of connection established between devices on the network. Here, which type of network is established? Ethernet network, or token ring, or FDDI. Which type of network is established between these devices is also identified by physical layer. Some of the components we used in network, such as repeaters, hubs, amplifiers, etc., are actually designed on this physical layer. These devices work on physical layer of the OSI model. The next layer is called as data link layer. Data link layer is actually a second layer of the OSI model. The data link layer receives a packets from the network layer and it is converted into frames. One of the job of data link layer is to take a packet from the network layer and convert them into frames. For that frames, some additional bits is attached at the top, beginning as well as end. Okay, a bit pattern will be attached for the frame to understand or identify a frame. That is called as framing. Framing means creating a new frame from packet. One more job of data link layer is error detection and error correction. When you send some data from source, it is in the form of bits. it will transmit the data using a physical layer and send it to the destination in the form of bits. When it received at the receiver, there may be a possibility that some bits may be corrupted. The data received is not correct here. So it is the job of data link layer to check whether the data frame contains any errors. For that one, data frame add additional information at the tailor side. Okay, and it will identify whether the frame is corrupted. If it is possible, it tries to correct the error. It is called as error correction. It tries to correct the error. If it is not possible, it will send a negative acknowledgement to the sender. If the data frame is correct, there is no problem in the frame, then it will send the positive acknowledgement to the sender. One more job of data link layer is flow control. Flow control means whenever the data is transmitted over a network, the sender and receiver should have the same phase. That means the data frame sent by the sender is same amount as data frame received by the receiver. The speed of between these two must be same. If sender sending the data at higher frame rate, means it will send more frame and it will receive less number of frames, there is a possibility of some problems. It is one more job of that data link layer is flow control. The next layer is called as physical addressing. This data link layer also provide some physical address called as MAC address. Each computer is identified in a network by unique MAC address. Actually, this MAC address is physically located in your network interface card that is used by this data link layer for transmitting. The next and the last job is access control. Whenever you are connecting a computer in a network, the same link is shared by many computers. Then this data link layer decide which device has to transmit in the physical medium. That is, access control is also done by data link layer. For example, see, there are many computers are there here. Many computers like this way. Here they are actually connected by a single line like this way. This was just an example. Now, if two devices want to transmit a data, then this data link layer will decide who will transmit first and who has to wait. That is called as access control. Okay, some of the job of data link layer is framing, error detection and correction, flow control, physical address, that is the MAC address. The last one is called as access control. The next one is the network layer. The network layer is responsible for the delivery of individual packets from the source host to the destination host. The job of network layer is to take the data from the transport layer and convert that into packets and send it to the data link layer. What actually do? This can be achieved by arranging the data into data packets. Okay, these data packets are also called as datagrams. What actually the network layer will do, it will create a data packets and adding a header to that one. The header part contain the source as well as destination address of the data packet. It is responsible for finding the path through which data packets can be routed to the destination computer. For this, it will follow two processes. One is called as routing and forwarding. Okay, routing and forwarding it will perform. It is the concern of network layer. Reliable and ordered delivery of packets should be done to the destination. Some of the components used in the network layers are routers. Routers are actually work on network layer of the OSI model. Some of the routing protocols we used are TCP/IP, IPX, SPX, and AppleTalk. And some non-routable protocols we use are NetBEUI, NetBIOS, SNA, and LAT. Now, imagine we want to send some data from a computer A to computer F. Now, how actually it will done from the network layer? Before explaining about the network layer, first I will explain about the data link layer. How actually the transfer will be done. Now, if the message has to be transferred from A to F, the data link layer create one data frame. Okay. Now this data frame contains the address of B. That is, the data link layer can only transfer the data from its adjacent node. So it will add the address of B. So the data is given to B. Now the same packet has to be delivered at E. So this node convert the destination address from B to E. Means the data frame is changed here. The header of the data frame is changed here. Okay. Now the header contains, instead of B, it contains header is E. Now it is delivered to the E here. Again, here the data frame is changed and the destination address is changed to F. On each, next one is the software components. There are 4 different types of software components are there: protocols, device drivers, network operating system for server, and network operating system for clients. I have already explained about protocols. Protocols are actually nothing but a set of rules that the computer on the network without modifying the packet. You just forward that packet to the E. E also knows that where actually take the goes to destination delivery and identifies what is the destination of the F. So it will send that packet to the E without modifying the packet. You just forward that packet to the E. E also knows that where actually F is located and it is forwarded to F. So the same packet is delivered from A to F. So it is called as source to destination delivery. That is actually the main job of networking layer. The next one is the transport layer. The transport layer take the data from the session layer and convert that into number of segments, give it to the network layer. The main job of transport layer is it is responsible for the delivery of message from one process to another. Okay. Now these are some of the main tasks performed by the transport layer. This layer is actually responsible for ensuring error-free end-to-end data transfer to the destination computer. What is the meaning here is, when the data is transmitted to the destination, if the transmitted data is successful, it will send one acknowledgement to the source computer. If the data transmission is wrong or something error is there, it has to be retransmit the data. That is the job of transport layer. One more job of the transport layer is it will manage the flow of data packets between computer across the multiple networks. That means if more than one packets transmit from the source, the destination has to receive at the same speed. If the data transmission is more than the data receiving, okay, what is the meaning here is, if this is the source computer and this is the destination computer, okay, now it has to transmit the data here like this way, and it will send a number of different segments. It will send number of segments here. The rate of receiving this segment is very slow. The transmission is fast and receiving is slow, because it is containing a high-end machine, it is a low-end machine. The sending is fast, receiving is slow. So what happens here? The data corruption may occur due to overflow. To overcome that problems, the flow control is actually managed. Flow control means data will be sent at the same speed as the receiving speed. The next job is actually here segmentation. Segmentation means what actually? The data is actually contains a large message. It is converted into small messages called as segments and send it to the destination here. And the ordering is also managed by the transport layer. Okay, it should be reached at the proper order. Means sequence number is given to each this segments. That is called as segmentation and reassembly. Next one is called as the connection control. In the connection control, there are two types are there. One is called as connection oriented and another one is called as connection less protocol. In connection oriented protocols, what happens? These data packets carries a path of destination along with it. It generates the delivery of the data packet at the destination computer. In connectionless protocol, the delivery of data packets to the destination computer is not guaranteed. What is meaning here is, now when you are sending some data from source to destination, here like this way, it is made up of here a number of routers like this way. In between there are number of routers are there. Okay, when the data has to be sent from here source to the destination, what it will do? It will make one connection here. Okay, it will create one virtual connection so that the data has to be reached at the destination. And all the packets are transferred using this virtual connection. That is called as connection oriented. In connection oriented protocol, it will transfer over a same line here. Okay. In connectionless, what happens? It contains multiple packets or segments. These data are sent. There is no connection will be established. So it will just no connection will be established between source and destination. So what actually it will do? It will send the packet to here. Some of the packets is transferred to here, and some of the packets is transferred to here. And each packet take its own route. Each packet take its own route and deliver it to the destination. In the second protocol, there is no guarantee that the packets are actually received from the receiver. So connection oriented protocols are more safer than connection-less protocol. The next job of the transport layer is error control. Error control means what actually? When you are transmitting the data here from source to destination, there is a possibility of some data loss. Here, it will add some error checking code to these data packets. Okay, that is called as CRC. Some of the error checking codes are added to the header here. Whenever it is received by the destination, it will check this header and identifies whether this packet is damaged or not. That is called as error control. If that packet is damaged, again it gives the negative acknowledgement to the source, and source has to retransmit it. That is the job of transport layer. The transport layer do some of the work same as data link layer, such as segmentation, flow control, error control, etc. But here the transport layer works at end to end. That means from one network, a computer in one network, into the computer in another network. But data link layer works on same network. That is the difference. And the last one is called as service point addressing. What is the meaning of service point addressing? Now see, in your computers, you are running many applications. In similar way, at the destination, he is also running many applications. So when these applications using the network for data transmission, when you transmit some data over this line, when you transmit data over to this line, okay, it is the job of the network layer to transmit the data safely to the destination. But once it is received by the destination, the destination has to understand this packet is used for which process or which application. That means if email is sending from here, and email has to be received at the email application. So this computer has to understood, okay, which application has to be delivered. Okay, that is called as actually service point addressing. Means in a source computer, the application which send, the destination computers, the application which received, it is identified transport layer. from the computer A to computer F. Now how actually it will done from the network layer. Before explaining about the network layer, first I will explain about the data link layer, how actually the transfer will be done. Now, if the message has to be transferred from A to F, the data link layer create one data frame. Okay. Now this data frame contains the address of B. That is, the data link layer can only transfer the data from its adjacent node. So it will add the address of B. So the data is given to B. Now the same packet has to be delivered at E. So this node convert the destination address from B to E. Means the data frame is changed here. The header of the data frame is changed here. Okay. Now the header contains, instead of B, it contains header is E. Now it is delivered to the E here. Again, here the data frame is changed and the destination address is changed to F. On each delivery here, the data frame is changed and reach the destination. So it is also called as hope to hope delivery. That means the data link layer can connect only adjacent node within the network. Now, if you want to send the data to the computer which is outside the network, just like here, A to F. Now we are using network layer. How the network layer works? First, it will create a packet and add it a one logical address here. This logical address is also called as IP address. This IP address is source as well as destination IP address is stored here, and give that packet to B. B is nothing but actually intermediate system, also called as routers. These routers knows where that destination is located. It reads the IP address and identifies what is the destination of the F. So it will send that packet to the E without modifying the packet. You just forward that packet to the E. E also knows that where actually F is located and it is forwarded to F. So the same packet is delivered from A to F. So it is called as source to destination delivery. That is actually the main job of networking layer. The next one is the transport layer. The transport layer takes the data from the session layer